In this video, we'll be looking at another more complicated example of the trapezoid rule, specifically a trapezoid rule that has 10 rectangles as opposed to 4. Now, in this particular value or integral, we're going to go ahead and start off with the integral from x equals 0 one more time to going to 4 of x squared dx. So that means that if I'm looking for my delta x, which remember is the base of each trapezoid, is going to be b, which is 4 minus a, 0, all divided by, in this case, 10. So that gives me 2/5. Now recall, like other Riemann sum problems, we can go ahead and take that 2/5, that delta x value, and we can simply remove it from the grand scheme of the formula. If you'll notice up here that delta x is multiplied by everything, so we could take that delta x and shift it to be outside of the summation so it doesn't get in the way. You'll also notice something that I'm going to go ahead and do with this, and I'm going to try and simplify this set of values to make our life a little bit easier. So I'm going to start writing out the first couple of terms, and hopefully you'll be able to see something. So the first couple of terms is, one more time, 1/2 multiplied by, and I'm going to have to figure out what my number line setup is, because in this case I want to try to avoid drawing out as many trapezoids as possible. I'm going to start at 0, I'm going to end at 4. But I'm going to move by a distance of 2/5 each time. So I need to cut this thing up into 10 pieces. So if I do that, let's see if I can do it as evenly as possible. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And again, this last section is a little bit off, but all in all, that's not bad. So this is first set is 2/5, then 4/5, then 6/5, because all we're simply doing is going from one to the next. We're adding the distance of 2/5. So 8/5. The next one would be 10/5, which is 2. Then 12/5, 14, 16, 18, and then finally 20/5, which is nothing more than 4. So we have all of those values written out. Now in my first interval, if we follow the rule, the height at 0 plus the height at 2/5 divided by 2. So there's my divided by 2. I want f of 0 plus f of 2/5. I want that thing to be multiplied by my 2/5 value, delta x. That is the area of the first rectangle. Now you're looking at this going, this is going to be really obnoxious to go through every single one of these cases. And you're right. So let me go ahead and write out the area of the second trapezoid, and you should be able to see very clearly maybe a pattern might start to emerge. So this one right here again is a sub 2. And I'm going to add to that another one, a 1/2 multiplied by f of, instead of my endpoint being, again, I'm in this one right here. So this is a1, this is a2. Now I'm creating a 3. That's between 4/5, so f of 4/5 plus the f of 6/5 multiplied by, again, the 2/5 value. So we've got a1, we've got a2, we've got a3, and then this pattern should continue. Yes? So eventually I'm going to go ahead and do add ... until I get down to the last interval, which is this one right here, which is again 1/2 f of the first value is 18/5 plus the last value is f of 4 multiplied by 2/5. Now, like I said, this gets really convoluted really quickly, but if I'm very careful, I can very slowly and identify exactly some things that are in common. So you'll notice the 1/2 is in common for every single one of these blocks. You'll notice that the 2/5 multiplication is in common for every single one of those blocks. So I can go ahead and factor out a 1/2, and I can factor out of 2/5. What does that leave me with? Well, it leaves me with 1f of 0, but you'll notice I have two different f of 2/5. Secondly, I have 2f of 4/5. 2f of 6ths if you look at this one and then the next one, and so on and so forth until you get to f of 18/5, which will have one in the previous step, and then finally f of 4 all by itself. So it will actually be 1/2, that value there, multiplied by my delta x, that value there, multiplied by, it's going to be f of 0 plus 2f of 2/5 plus 2f of 4/5 plus 2, technically 2 times every single one of these values, very quickly, f of 4/5, f of 6/5, plus 2 f of 8/5, plus 2 f of 10/5, which again is just simply f of 2, plus 2 times f of 12/5, plus 2 times f of 14 fifths, plus 2 times f of 16 fifths, plus 2 times f of 18 fifths, and then plus finally the last term. Remember, there's no two terms of that, so it's just single f of fourth. So this provides us with a way that we can hopefully condense and simplify how we evaluate certain functions. You'll notice that the rule then becomes 1/2 times delta x, and I'm going to write this formula down, is 1/2 times delta x times f of x1 plus 2 times f of x2 plus 2 times f of x3 plus, until I get down to your last term, I'm going to write out 2 times f of xn minus 1 plus finally a simple f of x sub n. So this is the actual formula that we can follow that might clean up a little bit of the work, so we don't have to do these area formulas every single time we do these trapezoid rules. So in the end, we'll just have to simply evaluate every single one of these, multiply the appropriate ones by 2, and condense and simplify the remainder of those values. In this case, it's simply going to be out here 1/5 times all of that work. Again, I'm not going to do that because that's just nothing more than number crunching. Again, this becomes 0 squared plus 2 times 2/5 squared. Because again, remember, we're trying to approximate this function. So that means that every single one of these f of blanks are simply that number squared. Again, evaluating that should give you an approximate number relatively close to 22, but a more accurate representation of the integral of x squared.